Welcome back, friends. This is session number 15 and this is the overview of automatic recovery. Now, every RDBMS has this feature. To my understanding, I have seen this in Oracle also. I have seen this in SQL Server also. And they use the concept of logs and that is automatic roll forward or backward or point in time recovery. They have some kind of option to recover the database. In fact, if something goes wrong, if some power failure happens, then the transactions are rolled back and incompleted transactions are rolled back. So automatic recovery process starts if something goes wrong. So however, we can configure and monitor and fine tune the recovery based on our need. So basically this particular session is all about understanding the parameters, stored procedures, which can help you in fine tuning your recovery options for Sybase Adaptive Server Enterprise. Okay, so tracking the database changes. SAP ASE uses transactions to keep track of all database changes. A transaction consists of one or more TSQL statements that succeed or fail as a unit. This definition, I'm sure, is nothing new because you people are all DBAs. Each SQL statement that modify data is considered a transaction. Users can also define transaction by enclosing a series of statements with begin transaction and end transaction block. So the name may change, begin transaction and transaction. The syntax keyword might be different for different RDBMS, but the concept is same. The transaction, which is multiple statements grouped together, executed as single unit. So the failure or success happens as single unit rather than individual statements. Each database has its own transaction log. The system table syslog. Okay, you cannot turn off transaction logging. That is mandatory. Tracking database changes. The database transaction logs is a write ahead log, meaning when a user issues a statement that modifies the database, SAP writes the changes to the log. After all the changes for a statement have been recorded in the log, they are written in the in-cache copy of the database. Interesting. So first logs are written and then they are written in the in-cache copy of the database, actual data. If any statement in the transaction fails to complete, the SAP ASE reverses all changes, that is rollback, made by the transaction. SAP ASE writes an end transaction record telling the transaction is end to the log at the end of each transaction, recording the status of the transaction. Each time you restart your SAP ASE, it automatically performs a set of recovery procedures on each database. The recovery mechanism compares each database to its transaction log. It is similar to Oracle, that what is stored in the header file, what is the status. So if the log record for a particular change is more recent than the database, then the recovery mechanism reapplies the change from the transaction log. As you know, as I discussed in the previous slide, transaction logs are written ahead of the actual database. So if the transactions were ongoing at the end of the failure, the recovery mechanism reverses all the changes that were made by the transactions. So this is concept of automatic recovery. Automatic recovery, basically it recovers master, it recovers Sybase system procedures, recovers model database, recover temp DB. The sequence is recover system temp DB, recover system security, and recover user databases in order of by Sybase databases.dbid or according to the order specified by the most important parameter to change the priority, my friends, SP_DB recovery order. Point is clear. I have 5 databases. but one particular database I know is the most important for me compared to 4 other databases. So I'll change the order, priority order of that database by using the stored procedure. I have discussed the examples in the lab assignment, which you'll try to execute, and you will see the order changed, how the order is changed and what will happen. Okay, so DB recovery order. Checkpoints. A checkpoint writes all dirty pages that have been modified in memory but not on the disk. You know, a dirty page means the same thing, that the page that have been modified in the memory but not written to the disk, so which are not part of the database, which is not a consistent part of the database as of now, which is already right now only in the memory. Okay, since the last checkpoint to the database device. A SAP ASE automatic checkpoint mechanism guarantees that data pages changed by completed transactions are regularly written from memory cache to the database devices. So we have automatic concept of checkpoint, and this mechanism guarantee that transactions are the changes, data pages, the changes in the data pages whatever made by the transaction are regularly written from the memory to the database device. We have a command if we want to do that from our side, and that command is checkpoint. It writes all dirty pages to the database device. You can use a checkpoint with each archive. It's a kind of, you can say, doing a commit. So you can use a checkpoint in an archive database. However, the checkpoint process does not automatically checkpoint an archive database. You can use this checkpoint only as a precautionary measure in the special circumstances. Okay. Now SP_DB option, the most important option, which I have discussed with examples in the lab assignment, automatically defaults to using checkpoint when you change a database option. You can specify one or more databases to run checkpoint as per your need, and to run a checkpoint all against all databases, you must have SA_rule or OPER_rule to give this command to issue the statement. The statement is comparatively straightforward. The command is simple: checkpoint all or a particular database name. Multiple databases, you can specify the database name. So what does it mean? You can use this checkpoint command to write the dirty pages to the databases. So in a way, manually committing all the changes and making the flush out the dirty pages to the device. Example: write all dirty pages in the current database to the database device. Simple, nothing. Simple checkpoint, one word, enter. Setting the recovery interval. Typically, automatic recovery takes anywhere between a few seconds and a few minutes per database. The amount of time depends on the size of the database and the size of the transaction log and the number of and size of the transaction that must be committed or rolled back. You can use SP_configure with recovery interval in minutes. So we have the SP_configure stored procedure, as we have understood, to configure the parameters. The default value is 5, which allows a recovery within 5 minutes per database. To change the recovery interval to 3, you can use SP_configure recovery interval in minutes 3. That's how you can configure, you can use this SP_configure parameter. Automatic checkpoint procedure. Approximately once a minute, checkpoint task checks each database on the server to see how many records have been added to the transaction log since the last checkpoint. If the server estimates that the time required to recover these transactions is greater than the database recovery interval, SAP issue a checkpoint. The modified pages, which means that modified pages will be written to the from the cache to the database device, and the checkpoint event is recorded in the transaction log that checkpoint has happened. Then the checkpoint task sleep for another minute or so. To see the checkpoint task, you can execute sp_who. The checkpoint task usually appears as checkpoint sleep in the CMD column. If you look at the sp_who. So sp_who, when you run it, and there's a column called CMD, and you can see that checkpoint sleep. Truncating the log after automatic checkpoint. System administrator can truncate the transaction log when SAP performs an automatic checkpoint. To set the truncate log on checkpoint, chkpt, this is the parameter actually, database option which truncate the transaction log when the automatic checkpoint occurs, we can use sp_db option, because this is the important stored procedure which will change the behavior of this truncating the logs or doing the stuff for that purpose. sp_db option. The database name truncate log on checkpoint is true. So this is how you can set this parameter. This option is not suitable for production environment. Why? Because it does not make a copy of the transaction log before truncating it. So therefore you may end up into a disaster. So advisable not to change this. Use a truncate log on checkpoint only for databases whose transaction logs cannot be backed up because they are not on a separate segment. If that is the case, then you can use it, and you can also use it for test databases for which current backup are not that important or not, data is not that crucial. Fast recovery. During a server restart, after a planned or unplanned shutdown, or during high availability failover, a significant portion of time is spent on database recovery. The goal of fast recovery is to enhance the performance of the database recovery, recover multiple databases in parallel by making use of available server resources and tuning them intelligently. And also it can be used to provide multiple checkpoint tasks at runtime that can run concurrently to minimize the work at recovery time. And this is the advantage, the goal. Now, startup sequence of SAP ASE is: system databases are recovered on engine 0. SAP ASE accept user connections. All engines that are configured to be online during startup are brought online. User databases are recovered in parallel by a self-tuned number of recovery tasks using the default data cache tuned for optimal recovery performance. This is the sequence of startup. Bringing engine back online. Engines are brought online after system databases are recovered, and therefore before the user databases, allowing user databases to be recovered in parallel and makes the engine available for online activities. So engines are brought online in this fashion only during startup. In all other circumstances such as failover, engines are already online on the secondary server if you have. Parallel recovery is a very good option. Databases are recovered in parallel by multiple recovery tasks during startup and failover. The database recovery is an input-output intensive process. You know it because it's going to take a lot of going to perform a lot of input-output operations. The time to recover SAP ASE with parallel recovery depends on the bandwidth of the underlying operating system IO subsystem. The IO subsystem should be able to handle the SAP concurrent IO request. So that means it goes to the IO request, input-output process by the operating system. So operating system should be capable of handling concurrent requests sent by the ASE server. With parallel recovery, multiple tasks recover user databases concurrently. The number of recovery tasks is dependent on the configuration parameter. The most important again for recovery purpose, max concurrently recovered DB. So if you take a note of this parameter is going to help you in performance tuning based on the operating system you are using and based on how many concurrent connections you can have or concurrent parallel recovery operations you can execute. The default is 0, which indicates that SAP ASE adopts a self-tuning approach. If you are well versed with your operating system and you know your operating system very well and it can handle concurrent connections, parallel recovery operations, then definitely you can change this value to recover the database faster. So obviously the DBA has to take a call on this issue. During parallel recovery, the system administrator can force serial recovery by setting max concurrently recovered DB to 1. So by default it is 0. It will take self-tuning approach based on the operating system available and the resources available. However, you can fix it as sequential rather than parallel if you change this max concurrently recovered DB parameter to 1. The database recovery includes checking buffer pool size and setting async prefetch. Yeah. Yeah, that is basically by default it will include a self-tuning approach, meaning that depending on the operating system resources. Yes, go ahead. Single recovery. Yes, at a time only one database will be recovered. One operation will go on. No, it is not default. Default is 0. Hmm. Okay. That is based on the DB ID. However, you can change the priority, which I'll discuss in a few minutes from now. You can change the priority based on your need, which I discussed. There is a parameter for that purpose, which I just discussed in 2-3 minutes from now. Okay. So SAP ASE database recovery includes checking buffer pool size. Yep. Yeah. No, that is for all databases and at a time. At any point in time, it will recover one and with only one operation, one recovery. That is the most important point. What is discussed in the previous point? Recovery is what? Multiple recovery tasks during a startup or failover. Now, recovery task does not mean that we are talking about one database or multiple databases, right? It is one recovery task. On one database, we may execute multiple recovery tasks, right? Now, whether we want to execute, yeah. Now, point is, let me clarify once more. Point is, if we have let's take example. I have 5 databases. Okay. Now, each database may be recovered using multiple recovery tasks, multiple operations going on parallelly to recover the database fast. Now, whether it is multiple operations will go on, multiple recovery tasks will go parallelly, or only one recovery task will go on this particular database at any point of time, that will be decided by this parameter max concurrently recovered DB, right? So if we say 1, then it will be only one recovery task will go on. But if we set it to 5 or 10, then all 5 operations, five multiple recovery tasks can go on at any point in time. Okay, so we'll see that in the parameter, and you will understand that with examples. Okay, so I'll talk about this because we have example for this explaining this, right? So and you can change the priority also. If I have 5 databases, if I want database number 4 to be executed first, to be recovered first, so that priority can be changed as Bommy asked. Okay, SAP ASE Database Recovery include checking buffer pool sizes and setting async prefetch. Okay. Log IO size. SAP ASE uses the largest buffer pool available in the default data cache for log IO. Okay. If a pool with the largest buffer pool is unavailable, the server dynamically creates this pool. If you are using async prefetch. Async prefetch limit. During recovery, the server automatically sets the local async prefetch limit for the pool in the default database cache used by recovery to an optimal value. When recovery completes, the original configuration values are restored. Okay. We can specify the recovery order. This is what I was talking about. You can specify the order in which databases are recovered for all or a subset of user databases. Choice is yours. You can use this stored procedure sp_db recovery_order to configure more important databases to be recovered earlier. Okay. sp_db recovery order has an additional parameter including the online ordering. The syntax is sp_db recovery order, database name, recovery order, force or relax or strict. Relax means databases are made as they recover, default. Strict means databases are specified by the recovery order. The default is relax, which means that databases are brought online immediately when the recovery has completed. So this is the recovery order, and you will do examples discussed in the lab assignment to understand this recovery order. Specifying the recovery order, for example, to insert a database into a user defined recovery sequence without putting it at the end, you can use recovery order and specify force. For example, if database A, B and C have a user defined recovery order 1, 2 and 3, and you want to insert pubs2 database as the second user database to recover, you can use sp discovery order db recovery order pubs2 to force. So this means you are changing the order. You are inserting pubs2 at position number 2 rather than 1, 2, 3 rather than ABC. So you are changing the order of recovery and you are setting your own database to be recovered on a priority basis compared to the ABC database. Changing or deleting the recovery position can also be done. To change the position of a database in a user defined recovery sequence, delete the database from recovery sequence and then insert it in the position you want it to occupy for the purpose of recovery. If the new position is not at the end of the recovery order, you can use the force option. By default, of course, it will be added at the end. To delete database from recovery sequence, specify the recovery order of -1. So you can simply remove it. For example, to move the pubs2 database from recovery position number 2 to recovery position 1, delete the database from recovery sequence and then reassign it the recovery order as we have done in the last slide. sp_db recovery order pubs2 -1. So this will remove it. Again sp_db recovery order pubs2 1 force. So we are making it ahead. In ABC database it was in second number, now it is on first number. So we have removed it from second position and we have put it on first position for recovery order. Okay. Listing the user assigned recovery order. To display that value, you can use sp_db recovery order to list the recovery order for all databases that are assigned a recovery order. To display the recovery order for a specific database, you can use the database name. For example, sp_db recovery order pubs2. So you will see that order. Okay, the database ID and the recovery order. So that's how you can check it and how you can display the recovery order of a database. Parallel checkpoints. A pool of checkpoint tasks on the list of active databases in a parallel. That is parallel checkpoint. This pool is controlled by the configuration parameter number of checkpoint tasks. Okay, the default value of a number of checkpoint tasks is 1 for serial checkpoints and the number of engines and number of open databases limit the value of this particular parameter. So what is the value of number of engines and what is the value of number of open databases? That will control the number of checkpoint tasks, which is right now, which is default 1 for serial checkpoints. To facilitate parallel recovery, configure the maximum number of engines to be online at startup, because that will help the parallel recovery. That will facilitate the parallel recovery. Recovery state. There is a global variable for this purpose. At the rate recovery state. It determines if SAP ASE is in recovery or not. Value at the rate recovery state can have what the values are: not in recovery, is not in startup recovery, or in failover recovery. Recovery has been completed and all databases that can be online are brought online. So right now it is not recovering. You can say that. Recovery tuning. SAP ASE is in a recovery, either startup or failover, and is going on right now and is tuning the optimal number of recovery tasks. Boot time recovery. SAP ASE is in the startup recovery and has completed tuning the optimal number of tasks. Not all databases have been recovered right now. And failover recovery means right now SAP ASE is in recovery during an HA failover, that is high availability cluster failover, and has completed tuning the optimal number of recovery tasks. All databases are not brought online yet. So this is a variable, global variable, which can be used to display the value, the current state, whether database ASE is in recovery or recovery tuning or not in recovery, or what is the current status. Tuning of fast recovery. Review of database layout, runtime configuration, and the database space according to setting to reduce recovery time. The database layout, runtime configuration, and setting space accounting. The database layout. Database should have logs and the data on their own physical device. The access patterns for logs and data are different and should be kept separate. The access pattern for logs and data are separate and are different, therefore they should be kept separate. Runtime configuration. Configure an optimal housekeeper wash percentage controlled by housekeeper free write %, so that during free cycle dirty pages are written out. This is a very good time, housekeeper free write %. This is a very good parameter which can help you in writing the data pages when the engine is not working on any other task. So on the free cycle, so it will flush out these dirty pages to the disk. The default is usually optimal. Setting space accounting. If the data space accounting is not essential for a database, you can set up database option to turn off free space accounting using sp_db option. So what you will do in the lab assignment is you will practice this sp_db option and the parameters which will affect the sequence of recovery, and there are many examples which I have discussed in the lab assignment. Okay, and that's it. This was the session all about this recovery, automatic recovery options, and changing the sequence and checking the sequence of recovery.